Guten Tag, everyone. That's German for hey, hi, hello. I don't know why, but my grandpa always says Guten Tag. I don't know why. I guess maybe it's because he lived in Germany for a couple years during the war. Anyway, so today we're going to be doing 10.7 Special Segments in a Circle, Part 1. There is only one theorem for this video, and the theorem says that if you have chords in a circle and they intersect with each other, you can split those chords up into chord segments. So if you look at this picture here, there are 4 different chord segments. So segments are parts of a chord. And if you multiply AB times BC, that is always going to equal DB times BE. Kind of interesting how that happens. We're actually going to take a look at a quick proof about this. So let's think about a way that we could actually prove that that happens. So we're trying to prove that AB times BC is equal to EB times BD. If we could prove that the triangles are similar triangles, perhaps we could set up a proportion that would lead to this final answer. How could we prove that the triangles are similar? We could use angle-angle similarity to prove that they're similar. I can already tell a vertical angle right here. So let's write down that angle ABE is congruent to angle DBC because they are vertical angles. So now we've got to prove that some of the other angles are congruent. Angle A is either going to be congruent to D or C, and angle E is either going to be congruent to D or C. How do we figure out how to prove that another pair of angles is congruent? We can't use alternate interior, alternate exterior. We don't know that line AE is parallel to line DC. We don't know that, and in fact, it looks like it's not quite parallel, so we need to do something else. Think about the theorems that we have learned about circles specifically. Yeah, some of those theorems about, oh, this angle is half of this angle, or this angle is equal to this arc. Think about the theorems that we've learned about circles specifically. What theorem could we apply in this situation to prove that a certain angle in the left triangle is congruent to a certain angle in the right triangle? Take a look at this right here. So this is angle EAC, and angle EAC is connected to arc EC. What's another angle that's also connected to arc EC? Angle EDC. If two angles share the same exact arc, what do we know about those angles? They are congruent. There was a theorem that said that if two angles share the same arc, then those two angles are congruent. So angle EAC is congruent to angle CDE because those angles share the same arc. All right, so since we already know that two angles are congruent, then we can say by angle-angle similarity, we can say that the triangles are similar. So we could say triangle EAB is similar to triangle CDB. And what do we know is true about similar triangles? We know that the proportion of their corresponding sides are going to be congruent. So side AB is going to be corresponding to which other side? AB is going to be side BD. Those are corresponding sides. And then also, let's see, we need AB in here, we need BD, so we need BC, and is that corresponding to EB? Yes, it is. So we can set up this proportion because they are similar triangles. So we're going to say because they're similar triangles, this can work. And now, all we have to do is cross multiply. We're going to multiply these. So AB times BC is going to equal EB times BD. And that is just because of cross multiplication. All right, so we proved it. Now let's take a look at how we can use this theorem to help us solve some problems. Here's the first one. We're trying to find x. According to our theorem, if I multiply 10 times x, that's going to equal 5 times 12. So 10x is going to equal 60. So x is equal to 6. And that's the answer. Here are two problems for you guys to try. Go ahead, pause the video, try these two problems, then you can watch it for the answer. All right, this first problem here, we're going to multiply 6 times x, and that's going to equal 4 times 15. So 6x is going to equal 60. So x is equal to 10. So that's the answer for the first one. And then for the second one, we're going to multiply x times x plus 12. And that's going to equal x plus 6 times x plus 2. We're going to use the distributive property here, and we get x squared plus 12x. And then we have to use FOIL over here. The first terms are x and x. When you multiply those, you get x squared. The outside terms are x and 2, so that becomes a 2x. The inside terms are 6 and x. And then the last terms are 6 and 2. When you multiply 6 times 2, you get 12. Now we're going to continue to solve this here. We're going to subtract x squared from both sides. And we're going to go ahead and combine these together. So we get 12x equals 8x plus 12. Then you can subtract 8x from both sides. So 4x is 12, which means x is equal to 3. So that's the answer for part B. All right, we have one last problem here, and we might have to take a few steps in order to do this problem, but it's a fun one. This problem here is about a rainbow. The true shape of a rainbow is a complete circle. However, we only see the arc of the circle that appears above Earth's horizon. What's the radius of the circle that has this arc of the rainbow shown? So we're trying to find the radius of the circle. That's our goal. How can we do that? Let's draw a picture that has the whole circle in it. It's going to be a little bit easier for us once we see a picture of it. All right, there it is. So this is a picture of what the whole circle would look like. So the rainbow is going to be just this top part right here. AC is the rainbow. And so we're trying to find the radius of the circle from D until F. Think about the theorem that we learned today. How could we use that theorem to help us solve this problem? We could use that theorem by saying, well, technically the diameter is a chord, kind of. It's a special type of chord that goes exactly through the center. So we could say, we could use the product property. We could say that if you take DB and you multiply that times BE, that is going to equal AB times BC. So that's what we learned today. So DB is 0.7 and BE, we're not sure what that is. So I'm going to label this with an X. And that's going to equal 2.5 times 2.5. Then we're going to solve it for X. We're going to divide by 0.7. So X is going to equal 8.93. We'll round it to that, 8.93, or 8.9 is fine too if you want to do that. So that's what X is equal to. So if we take 8.93 and then if we add 0.7, that's going to give us the entire diameter. So let's do that first. 8.93 plus 0.7. That's going to give us 9.63. So that's going to be the diameter of the circle, and this says what's the radius, so we just have to divide that by 2. So now we're going to divide 9.63 by 2, and we get that the radius is equal to, let's just round it to 4.8. So the radius of this circle would be 4.8. All right, guys, that's it for the day. Great job. Remember to submit your notes on Canvas and have a great rest of your day.